Here, our final thing is functional value. Okay, so when you see something written like this, this expression here is a function, sort of like example, was it 4, I think? Right? If I put something in, I'm going to get something out. I'm going to get one thing out each time. So f of x equals h of x equals, that's just a functional notation. It's telling us, it's naming a function. All right, this is telling me that when I see function h, I use the expression 4x minus 3. When I see the function p, I do x squared minus 3x. All right? So they give me two different functions here, and they ask me to do something with it. In this case, they're asking me to evaluate p of negative 3. All right? Two parts to this. P tells me which function to go to, and of negative 3 tells me what to change x into. So when I see p of negative 3, I go find function p of x. I go to the expression that p of x equals, and all the x's become negative 3's. Use good substitution technique when you do this. X is being squared, so every piece of x is being squared. X is the number in the parentheses. So negative 3, x squared, negative 3 squared means both the negative sign and the 3 are being squared. 3 times x, 3 times negative 3, and that's minus 3 times negative 3. So negative 3 squared is going to be positive 9, because again the minus sign and the 3 are both being squared. 2 minuses make a plus, 3 times 3 is 9. Minus becomes a plus, 3 times 3 makes 9, because 2 minuses make a plus. Subtraction can change to addition, doesn't change to multiplication. 9 plus 9 equals 18, there's my answer. The reason they might do like this problem like this, where they give you h of x and p of x, they might say find p of negative 3, find h of 4, and find p of 5 plus h of 2. So they might do stuff like that. So if they name several functions, they're going to be referring to them by name and then telling you what to change x to. Go to the expression, change x to that number, evaluate correctly.